Okay, good morning everyone. Are we having a good start to our day? Yay! Yes, I like engagement. So welcome, I'm Jade Bianca. I'm here representing Black Book AI, talking about predicting failure and automating defect detection on utility assets. I've also got my friends here, Tyler and Cooper, who you'll see a bit later on. So I'll run through our agenda very quickly for you. So Black Book AI and Pipe AI are two separate things, and we'll talk a lot more about that. Pipe AI is two separate components, and we'll look at both of those. We've got a lovely quick demo there for you. Tyler's going to come and chat a bit about ML ops in action and our model analysis. And we'll have a bit of a chat about some challenges and lessons we've learned along the way. And we'll have some time for Q&A with Cooper later. So this is Black Book AI. We are a pretty small company, medium-ish, growing in Australia. We've been around since 2017. We have over 150 staff, and we are all based within Australia at the moment. This was last year's Christmas party, which we had a lot of fun in. And we do a lot of things across a broad range of tech areas in AI, automation, data ops, and digital. Pipe AI is a collaborative project we have going on with a company called Peak Urban. It's an end-to-end solution for pipe condition assessment powered by AI. So how it started: ginormous pipes. If anything went wrong with them, we would have to turn off the water, get heavy machinery in, safety risks, dig the whole thing up, have a good look around, see what was going on, and then make decisions on what to do. Sometimes we'd have to dig it all up just to see that nothing was going on. Sometimes we have to just check how things are going. So this is a huge financial outlay, and of course there's safety risks for the workers involved as well as impacts on the community. This is a not exhaustive list of some of the defects that can occur in pipes. There are over 100 defects across 66 defect families. This is just a few. We've got this amazing little rover that travels through the pipes with a camera, records what it sees. And my friend, we're going to call Fred here, is an engineer. He spent 4 years at university getting a degree, not to sit in front of a computer all day analysing CCTV footage, but that's what he's ended up doing in the back of this little truck, watching everything that the little rover pulls out of the pipe and checking for anomalies. And this is what he sees on his screen for 8 hours a day. Our very first implementation was a single Alienware laptop. It was not on the cloud. It could not be scaled. We had one person who could do this. So what we're looking at now is actually some footage from in there. You've got a lot of information up the top of the screen there. We can see there's information about where this pipe actually is. We can see the kind of material the pipe is made of. And with the bounding box there, we can see that the AI is 98% confident that that is actually a junction within the pipe. All of this has happened without having to pull in any excavators, turn off anything, dig anything up. Saved a lot of time and money, and of course kept people safe. So the two components of Pipe AI are review and predict. Review looks at the CCTV footage with computer vision technology and identifies cracks, roots, all those defects that we looked at earlier using that footage. And predict then also looks at what condition the pipes are in to inform future maintenance and repair. Our ML model training continuously uses the data collected to retrain, to improve accuracy, to identify those defects with classifications for cracks, fine roots, or blockages. And as I mentioned, it can detect over 100 defects across 66 defect families. By using Pipe AI, the inspection process is automated. It works 24/7. The technology detects up to 15% more defects than a manual review and finds faults that humans miss due to fatigue or subjectivity. So our friend Fred, who was sitting in the back of that little van, had to sit there for 8 hours looking at all of that footage. He would miss things. Somebody else would then get his report and have to review it to check what had been missed, and even then, things could have been missed. So this is so much more effective and a better use of time and more accurate. The reports that come out from Pipe AI are configurable for our clients. They have a really nice looking front-end portal that they can use there. The analytics and the dashboards show different types of incidents that can occur or have occurred, as well as predicting whatever maintenance may be needed for the future. And that's based on the predict side of the model. So it can also use historical data to make predictions about future failures. So the finance teams are able to look at their budget for several years into the future. We also look at asset scoring, which uses information about the age of the pipes, what it's made of, even what is on top of it in the real world, whether it's suburban areas, whether it's rural areas, all of these things actually have an impact on it. And so we can score those pipes and assets for prioritising future inspections. And we can also have a look at the decisions made and see whether it's something that can be delayed a little bit or is more urgent based on those asset scores. With the front end, we have a one-click process to request an inspection for an asset, and it's reviewed based on that asset scoring system. So some of the benefits I have mentioned already is optimizing our budget allocation. Because we've been using machine learning, we can predict when our works are needing to be maintained, when something is likely to be needing to be completely overhauled, or when something's just going to need a little bit of maintenance. So the budget can be put ahead for up to 2 years. Our maintenance schedule is now going to be optimised, which is able to use our workers and our resources in the most appropriate ways, cost-efficient ways, and effectively, rather than having them going out everywhere and digging things up just to see what's going on. We know exactly where they need to be. Our footage review being automated saves a lot of time because we no longer need a man in a van to watch it all. We still collect all that CCTV footage and upload it into the portal where the AI now does the review and gives a report that is then manually checked. As I mentioned before, we reduce the cost of site inspections because the AI is identifying issues there, while our workers are able to focus on higher value work. Of course, all of these things lead to improved business efficiency and accurate recommendations and automations for what we're needing. So what it looks like in a little bit of a nutshell here. If we look at the number 1 on our screen, first thing we need to do is train our model to identify the defect classifications, and you can see there's a few examples there of cracks, roots, and blockages. The second thing it does is then uses the AI to review the footage and detect those cracks and anomalies. We generate a report, and then we move into the predict phase as well, using our CCTV footage to analyse the current and historical data to make those predictions. But what happens to poor old Fred? He is not out of a job. Fred has actually studied very hard to do much more important things, which means he is now available for drafting and planning systems to more accurately achieve our functions. He can look into thermal and stress analysis. He can look into more valuable engineering solutions for the piping we already have under our cities. And he is also able to do more thorough and specific targeted site inspections. In action, this is a little bit of our dashboard here that the user will see, and you'll get to see this a bit closer up in a moment when we look at our demo video. So using Predict, our user can actually see the location of the pipes geographically on maps, as well as all of this other information about the pipes on their dashboard. It's right there available for them to click through and look at. The scores and priorities for the assets are also shown there for them, and they actually are able to see images and video footage showing what anomalies and defects were detected in the AI, as well as being able to click into them and have a look and manually make adjustments if they think it's incorrect. Okay, so we've got a bit of a video here, and I'm going to step aside for a moment and let you enjoy it.
All right, thanks Jade. I'm Tyler, and I've predominantly been working on the sort of technical development side of this, all the way from the sort of rough end of things with that big chunky laptop that you all saw, and then sort of more recently, we've been moving things towards AWS and having a bit of a nice architecture, as you can see. And so I thought, given you're all here, there's probably a significant understanding around the different AWS services and the things that they offer. So I won't speak too specifically to how we're using Route 53 for the DNS side of things and how we're actually using the different subnets. But I kind of wanted to talk to the architecture in the same way that we've sort of spoken to our journey from where we started and where we've come to today. So essentially, when we began on the laptop side of things, these ECS clusters that we can see, they basically just began as Docker containers which were running quite locally, had some very basic configuration options, and the operator themselves would just access a laptop. And on top of that too, I think we were using some remote screen control sort of software to be able to debug and everything like that. So very bare bones, as you can imagine. And so sort of from that early days, not only have we sort of developed in our understanding around AWS, but also the product itself has kind of evolved alongside that. And so we've kind of been incrementally upgrading things now to instead have those containers living within an ECS cluster, which, as you'll know, that way it can actually sort of horizontally scale and provide that scaling. We have the proper logging available, so we're not just looking at sort of terminal output on a Docker container or something. And then we're using the EFS mounts and things for the local storage. So I think it kind of largely reflects our own journey in things where we went from this laptop that's sort of containing its own storage and everything else, and then we've tried to migrate things towards the AWS ecosystem. And I think there's plenty that we're still not fully leveraging when we look at an architecture such as this, but I think much the same as that's been occurring, and I mean the same way that you all will be doing here at the conference, we're going to be going around to continue to try and understand AWS, its evolving ecosystem, and continue to incrementally upgrade this like we have been throughout the years. And if there's any particular questions about that, we can cover them off in the Q&A. But so I think beyond the actual processing side of things, where we have the model sort of operating, the other side of things is then the actual training side to accompany the processing. And if we jump over to the next slide, this is sort of an abstract view at our retraining pipeline. So I think a significant benefit which we have operating in the space which we're operating in is that there is inherently someone who is a part of the process as an operator, who is a trained professional who can look at the results of the model, critique them, edit them, change labels, delete particular ones which are false positives, things like that. And so we inherently have this review process built in that's kind of abstracted away from the whole training process in general. So when we have a reviewer accessing the website, they're operating on it like they would their typical job as a reviewer, and not specifically with the intent of, oh, I need to train a model for this. And so that abstracts away some of that complexity that exists. So essentially how it works in practice then is that the reviewer themselves gets an output. It tells them, oh, there's a crack over here, there's a breaking in the pipe in these locations, and through using the interface, they can tell it, no, actually that's a different kind of defect, or that defect is actually a false positive. And with that data in the system then, as you can see, we end up with the data ending up inside of the database side of things. And then on a schedule, we can read from that database, take the data and the critiques that they've had, and automatically begin to retrain the model, using that as kind of a new ground truth side of things. And so with this, we think that we've kind of achieved a fairly symbiotic and fairly friction-free approach towards the retraining pipeline area of things. And I mean, same as the other areas, this will continue to evolve, but we've found that having that kind of abstraction where the worker can work within the space that they're familiar with means that we can kind of leverage the best of both worlds to integrate the AI with the existing industry. And so, yeah, on top of that, we just basically leveraging a Lambda to pull out the annotation data and to structure it correctly, to train the model, and then using a map score with the potential to integrate other metrics in the future to judge, is this model better or not? And then in your typical kind of way, ease out that new deployment of the endpoint to support the new model. So with those things in mind, we wanted to kind of give you an idea of how the model's actually performing and speak to a fairly more recent example which we've had. And so I think one key thing which I think we want to cover off first is that the bottom value figures where the 103 detected defects were from the operator, so the one responsible for watching that footage. I believe it was Fred in the van, essentially, sitting there trying to identify the defects, looking at these hours of footage. And then in our case, the 313 defects which we detected, which were all valid defects, highlighting sort of that difference between what an operator might miss and what our model is currently detecting. And I think the other part that we lean into with this logic too is, as with any AI problem, it's that balance between having too many false positives, but also not wanting to miss too many things. And in our particular case, when we're dealing with something like defect detection, missing quite a significant crack within a pipe is far more detrimental than an operator having to click and delete something. So in our case, we're sort of leveraging that logic to be able to try and detect things quite significantly and then allow them to instead review the process and therefore increase what we have actual coverage of. And so, yeah, across all 9 videos, there were the 12 false positives and 3 false negatives. So, I mean, as with any problem, as I said, it's a balancing game which we're still trying to get right, which we're still playing with, and which very much comes into the sake of when we're working with a client, what kind of risk do they have? What are they willing to prioritize between the 2 efforts? And then ultimately trying to get that best balance possible for them. So yeah, when it comes to the shorter term sort of side of things, as I said, this is kind of a growing journey. There's a lot that we still need to work towards and a lot of growth that we can do, but we think that we're in a really solid position already. So yeah, in the shorter term, we want to ultimately try and tweak the model detection thresholds. These are things which don't require full retraining. They're your typical sort of thresholding. And in our case, we have some object tracking and things in there. So the little things you can manipulate to try and improve just the overall experience. But then with the longer term, as you saw, we now have that retraining pathway in place. So as we get more and more clients actually leveraging the product and growing it from there, what that should ultimately lead to is a better model overall. And I think that also speaks then to the other sort of fundamental approach we've had towards our model side, which is we have this idea of a communal model, essentially. It's basically saying that those who come into the product can opt in to sort of leverage the data and the training which is being performed on everybody else's data that's doing the same thing. So all these different councils and clients and things, they all contribute their data to the training of the model, and the baseline model across all of them is trained up, and therefore they all benefit from each other's experiences, basically. And so I think longer term that will also benefit us with that retraining as the overall model just continues to improve and we get to expose it to more defects and those sorts of things. So then I guess we want to speak towards the challenges and the lessons that we've actually learned currently. So I think a significant challenge for us, perhaps, has been the scaling side of things. I'm sure many people have run into that kind of issue before. And we particularly just got kind of thrust into it when we ran into the case of how do we process hours of footage, essentially. We're suddenly dealing on the scale of hundreds of gigabytes, et cetera, on the way up. So I think that kind of data capture, curation, engineering side of things was definitely a big part for us, and something that more and more tooling has come out for that we've been able to leverage. And I think that's going to help us too for any future machine vision side of things as well. And then the other key one, of course, being from that predict side of things. So there's sort of the historical data that exists, which, as we all know, there can be holes, there can be very questionable quality data within there. So the natural question becomes how can we sort of fix some of that historical data, start working towards a better future process, and then in turn we'll be okay to continue from there. I'll pass it back now to Jade to sort of talk through the current plans, future visions, and sort of summarize these final items.
Thank you, Tyler. So looking at our current plans and future visions, obviously we've seen today a lot of talk about what happens in stormwater drains and sewer pipes, but there are other kinds of pipes out there. A recent project we undertook with one of our largest regional councils actually looked at rooftop using drones to look for blockages and obstructions around drain guttering on rooftops. One of the amazing benefits of this is, of course, going back to safety and the financial aspects. Normally, the only way they would be able to check this for any of these issues is to send somebody up on the roof to manually have a look and see if there's blockages in the drains or if the gutters need cleaning. Ironically, one of the largest causes of deaths on construction sites is people falling off roofs. So by actually being able to utilise drones and our AI technology to do this, we're minimising the risk to our workers, as well as being able to repurpose our finances in a more targeted way to where they're required. As for the future, Who knows? AI can be utilised and manipulated and changed to all kinds of different scenarios, and imagination is limitless, so I'm excited to see where it goes. And that is pretty much everything we wanted to cover. We wanted to leave a fair bit of time for question and answers, so Tyler will be back up here with me, as well as Cooper, who has been working on this project for quite a while as well, and we'd be very happy to take your questions.
If there are any questions, actually.
So how often do you push a new model?
Sorry, repeat the last part.
How often do you push a new model?
As far as, so new models or new sort of process versioning?
Yeah, so the question, I guess, was how often do we push a new model? So I guess that sort of comes down to client expectation or client wants. Some of the clients we look at doing weekly retraining, so they're obviously the higher volume customers that are pushing through terabytes of data a day. Others are looking at monthly, 6 monthly, or up to a year, depending on sort of how much actual utility assets that they have in the ground. Some of our larger companies or clients have hundreds and hundreds of kilometers, so they have those little robots that we saw before going through the drains all day, every day, 24 hours. So they have huge amounts of footage that sort of gets pushed through and via Direct Connect uploaded to the cloud, and then we start to process, and then through that process we go through that MLOps process. So yeah, client-based, it's driven by clients.
Yeah, I think the other part we found beneficial was not to think necessarily on a time scale, but more on a data availability scale. So ultimately, if there's not a sufficient amount of data come in, then it doesn't matter what time you're working with. It's more a question of, yeah, what data have we collected, how proactive is the client in using things, how many pipe videos do they see, that sort of stuff. So I think it's very sort of data-driven at that point as opposed to being time-driven, I guess.
And was there a question over there? Yep.
Yeah. How are you dealing with relative business risk that you identified on the slide relative to the potential risk of the actual defect? For example, on longitudinal, it's only like this big is different than this big, relative to risk.
Yeah, so a question in summary was how do we sort of balance that risk to sort of defect detection ratio for each client? So in Australia at least, so we're an Australian-based company, there is a sort of a guiding engineering code called WASA, and that sort of outlines based on each defect there is a grading, so a scoring that every utility company in Australia abides by, and so that sort of factors in that risk concept into the detections of defects. And then I guess the other element that we sort of have in there and that we touched on is that human in the loop. So there is that element of the AI will process the video, analyze the footage, and then give a summary to someone, an engineer, a civil engineer, to review and tick off before it goes any further with remediations. Yeah.
How much of the detection accuracy is dependent on the quality of the camera and the images versus the algorithm itself?
Yeah, great question. So the question was, sorry.
I would say that you invest a lot in higher end cameras that can be cited.
Yep. So the question was around how much does the quality of the footage affect the accuracy detection, and it definitely does. So we work with a range of utility companies in Australia. Some are, and we don't sort of handle the hardware side of things, we handle the software platform side of things. So we work with the client with their procurement teams and that sort of thing, and looking at their sort of future outlay in that machinery. But it is driven by the client that we're working with, and some have old cameras that are 480p. Others are looking at putting down cameras that are up to 4K in the pipes, and obviously with that becomes higher fidelity imaging that will result in better detections. So that's something that we balance and we look at specifically with the per client. So if they're sort of just looking at developing a model for their particular network, then that's something that we can tweak and sort of work with them on either improving their hardware or working around from the algorithm side on how do we counter the sort of lesser quality footage and what to look for there.
I think on that too, a great recent example that we've actually had is we've had a client approach us about using a fisheye approach. So as you can imagine, fisheye camera is just intended to try and capture the full pipe, and therefore rather than trying to pan and zoom and everything else, it just sort of passes directly through. And so as part of that, we sort of integrated into the pipeline the ability to try and remove distortion of fisheye to not only support the engineers who review the footage, because they've told us about the fact that it's just very hard to review even for a human in fisheye form. So we not only try and remove that distortion for the human, but to then be able to provide that regularized sort of side back into the model and utilize it like we would any other video stream. So I think that's been another case too where we've sort of met the hardware expectations that were needed.
And I guess just to further on from that, and it kind of ties into the sort of how often do we push a model, is that if we've trained a model on a certain set of data and we're still getting that quality data coming in from the field, then it's sort of comparing apples to apples. But if they've sort of upgraded a bunch of cameras and we start seeing better quality footage coming in, but their model is trained on lower quality images, then that's something that will trigger, okay, let's start to push a more regular model retraining as we get new data coming in. Yes, sir.
I guess ultimately your customers, their end game is going to be about the remediation path that you want to take based on the defects you're pointing out. And you mentioned about having a categorization of the risk profile. The question is, are you guys starting to look at how can you leverage some of your technology to recommend the remediation? Because I would assume in the business case that you presented, some of these defects are going to develop over time. So you're going to have some breathing room to remediate or take corrective action. Are you guys planning to expand the scope of what you're doing into the remediation realm?
Yeah, so the question was around, do we plan to expand the capability on remediation? So yeah, absolutely. But again, it is very much a client-driven thing. So some clients are much more focused on the review side of the product, and others are looking at the predict side, and as your question sort of stated, they're looking at how far can we take this. Obviously, each defect is different, and that WASA code that I mentioned earlier sort of outlines a lot of those defect classes and some of the factors that go into how quickly do they degrade, how quickly does it need to be remediated. But yeah, absolutely. And each, obviously, business will have their own sort of risk appetite for a defect for each defect class, and then for sort of like an asset class as well. So whether it's a vitrified clay pipe, whether it's a concrete pipe, that will sort of get factored into how urgent it is. And there is sort of like that ranking for high severity defects, low severity defects, and all the other sort of factors that go into a remediation schedule. But yeah, that's very much something that can be, that's on the roadmap and is already getting implemented at some of the larger clients.
So it sounded like that each week you're collecting more and more data, right? And you can't have a reviewer go through all of it. Can you talk about some of the challenges and what you did for those challenges when you were dealing with this continuously new versions of your own data?
Yeah, absolutely. So the question was, how do we tackle the large volumes of data and reviewing all that data? So I guess if we look at it, and we sort of touched on it before, but the harsh reality of reviewing these assets in the ground is that there is CCTV footage going on day in, day out, 24 hours a day. So there was always a large volume of footage to review. So before technology like Pipe AI came along, there was really a man in the van sitting there reviewing it as it was happening in the field. Then they would drive back to a data center, upload their data, and then a civil engineer again would sit down and go over the footage. So that was double handling 8 hours of footage every day for every asset, for every van that's out in the field. So I guess the first stage was just the very existence of technology like this allowed and is allowing companies to at least remove that second review of it, right? So there is still someone out in the van capturing the footage, and then it gets uploaded to their data center, which we then, via Direct Connect, Private Link, and other sort of technologies that AWS provide, it gets it up into the cloud efficiently and then starts to process. So, and then provide a summarized form. So that's sort of like the first efficiency that we had. The end goal, and sort of touches on that future state of technology like Pipe AI, is that we, as robotics improves as well, we will have autonomous drones out, or drones sort of out in the field going through these pipes. So that would reduce the need for a man in the van. And then that footage then would be automated in Pipe AI, reviewed, and there will be a level of trust there after it being implemented within a business for a number of years, that there won't even need to be that review process. So it's sort of slowly taking that human in the loop out of the process over a period of time. But to sort of answer your question, is that the exact existence of it is reducing the amount of review time that needs to be done anyway, and then that's only going to get better over time.
And then I think, sorry, just on
No, you
that,
go.
like on the technical side of that then too, so we're capturing all this ultimately in a database, including the actual annotations themselves, because they're just coordinates. And so as far as our ability to sort of catalog the data, query against it, timestamp it, etc., we got all the metadata there available to sort of build out our data ops pipeline side of things. And so I think that sort of gives us a solid base as we continue to grow that capability. And then on top of that, the model itself is being evaluated just from a map score currently, just with the mean average precision. But we can ultimately then expand that Q&A step to try and capture more, like better reflective performance areas. So I think with those two things combined, we can kind of manage the data, manage the model, and then just kind of build those capabilities.
So my follow-up question is going to be that, do you have any metrics which track the data quality?
Yeah, so the question was about the metrics that we use to track data quality. So I think it's that sort of comparison between, we both have what we kind of say as the quantitative side, so the map scoring and the typical metrics which you have for machine vision. But then on top of that too, we have kind of the more human-driven side, I guess, so to say, where, like with the review that you saw towards the end of the slides, where we actually have sort of a breakdown of these many defects were identified by an operator, this many were identified by our system, and so it kind of speaks a bit more to that experience side of things. And I think the key distinction there as well is that the model itself is ultimately just detecting on frames, as we know. So it's detecting on frames, trying to see objects in each frame independently, but then the actual processing itself is also doing things like the object tracking in that, to try and associate the different detections over time to make it one object, for instance. So we not only need metrics which cover how the model's performing in like a quantitative kind of way, but also just how well the whole pipeline is functioning and what kind of an output does the human ultimately see, I guess. So I think it's been balancing those metrics between the quantitative and qualitative sort of side.
All right. Any last questions? Awesome. Well, thank you all for coming out. It was a pleasure, well, not so much me, but these two, I'll speak for them, a pleasure presenting to you all. And if you do have any other questions, we can continue it anywhere. We'll be here all week. Thank you.
All right, thanks all.
Thank you.